Okay, let's start. Hello, Crete. Hello, everyone. Today, I represent a net company, being in the management of the artificial intelligence team in Greece. I will deliver a quick speech regarding AI technology and current trends. And if you have possible questions, you can keep them for the end of this session. Well, Net Company at a glance. Net Company was founded in 2000 in Denmark, providing intelligent software solutions, has presence in Europe and Vietnam, with over 8,000 employees, a high percentage of women, and over 50 nationalities. Here's the subject we are about to cover today. A few things about Gen AI models, some architectures, the challenges today, evaluation of them, and current trends. Let's start. We will talk about the engine of modern AI, basically LLM, which are the evolution of statistical and natural language processing algorithms. LLM types are depicted in this diagram. You can see they categorized by their parameters, type, availability, originality, and the data they can handle. Regarding parameters, the higher the parameters, the stronger the models. But small language models are the future. Because have less cost and they can fine-tune easily to perform, let's say, very accurately in a specific task. We have the fine-tuned and the original models. The availability, if the internal parameters of the model are publicly available or not. Private example is the GPT architectures, and the public, the popular Llama from Meta. And we have the types, the foundation model without any instruction at all, or fine-tuned for instruction following, called instruction in chat, fine-tuned for chatting. We have the multimodal LLM, which is the next step of the traditional LLM. Can handle all type of data, audio, video, images, and so on. And we have the current ChatGPT architectures, where you have many underlying models. They understand the user's intent and they pick the model that is adapted to the task that they should perform. From the open source models available today, Llama from Meta, Qwen from Alibaba, and DeepSeek are considered the most powerful ones. If your application requires complex problem solving, mathematical accuracy, and so on, then DeepSeek is the way to go. Currently, this month is released 3.1 version. If you need a versatile model with a wide range of tasks and multilingual characteristics, very strong ones, then you will go to the Qwen. This month also is released the third version. Currently 2 or 3 days ago. And Llama from Meta is an all-around model supported by the research community. So it is one of the most reliable models which are open source to use in the market. What are the current AI system structures today? We have the traditional RAG systems and the agentic RAG. You know, RAG systems are the ones that they retrieve information not publicly available mainly, let's say internal documents or internal information that we would like to, let's say, insert this information into the model, take it into account, and give a response based on this data. Currently, the documents are transformed into embeddings. The embeddings are stored into the vector database. Then the query find the relevant, let's say, results. A model analyze these results and give the final response in a natural human language. What's the difference with the agentic RAG? Agentic RAG can use multiple tools, web scraping, calculators, Python scripts to run, to do some actions. You can have multiple agents, you can have conditional executions, parallel executions, and so on. So it's a more complicated system. We called it agentic RAG, or agentic AI in general. These are, let's say, the current protocols, high-end ones. The MCP, multi-agent coordination protocol, and agent-to-agent protocol, they can coexist. What's the difference? The difference is that the MCP protocol, let's say, is like the agent itself autonomously chooses the tool that is adapted on the task that the user wants to. So from centrally, let's say, situated resources, that's why we have a server and a host. And the A2A protocol, agent-to-agent protocol, mainly it's a collaboration protocol or an orchestration protocol where all external agents or all the agents can cooperate together in order to have a combinational, let's say, response. What are the top challenges we face today? We face hallucination, mainly misleading or false information. We have the compliance, mainly violation of privacy laws or industry's regulations. We have the security challenge, let's say, malicious actions that can lead to harmful content like phishing emails or deep fakes. Deepfakes are a kind of fake videos, fake images, and so on, which is, let's say, is a trend today. The security one, no, the bias one, where you have, let's say, to handle with unfair outcomes. So you have to solve this. And the other one is the prompt toxicity, which basically is, let's say, toxic prompts that can produce inappropriate or harmful content leading to violence and illegal, let's say, activities. Something important, no one talks about it. It is cost and accuracy regarding AI systems. As you can see in the left graph, the core idea is that the cost of using a conversational AI agent, which remembers the past conversation, let's say, the cost increases dramatically, let's say, with the length of the conversation. This is because the agent has to remember and process all the history, let's say. Let's say we have a comparison with a basic chatbot, which is called a stateless, let's say, agent, which has a flat cost. In this way, you have to take it into account, let's say, when you're building productive applications, in order the answer to be given without many conversation turns, because it isn't beneficial in the company otherwise. And the second one graph depicts, let's say, how the error accumulates when there are required many steps for the model to give, let's say, the final answer to the user. So if multiple steps are required, the accuracy drops by a lot. You have to have, let's say, nearly perfect accuracy in each step in order to have a viable system, if a system requires so much steps to solve a problem or something. So in production, you have to take these factors into account. There are multiple evaluation methods, embeddings-based, word-based, character-based, and so on. I will show you the suggested one methodology to evaluate these applications. The suggested one right now is to use another model to judge your application, depending on the task that your application handles. The next step is the user to provide feedback with a thumbs up, thumbs down, or a rating, and so on. We have the golden datasets, which are basically the evaluation dataset or the feedback datasets containing the ground truth. So we compare our response, model response, with real information. And the last one is business metrics. Metrics that are, let's say, more very important for an enterprise, like, for example, the number of the customer wants to talk to a human instead of the AI, or other, let's say, business metrics, the latency, the time required for a system to solve a problem, so on. There are two leaders in an LLM's performance. It is the LLM arena and the VLAM. You can see that a model could be evaluated in many tasks, from the text, web search, vision, to coding. And each of these categories contains also subcategories. For example, regarding text, we have reasoning, we have maths, we have long or short queries. Basically, no model today excels in all tasks. The highest model strength in overall tasks, let's say, is depicted in this graph. And the leader is the Gemini 2.5 regarding text, followed by the Claude model and the GPT architectures. And you can see other features that could be taken into account, the cost, latency, and so on. I will show you some examples with AI, with practical application in daily life. For example, we have a simple AI agent, a simple flow here. Basically, it's a system which adjusts the temperature based on Celsius, taking into account also, let's say, backup power. It's the simple, some simple applications are, let's say, email filtering or the simple customer support and so on. But the evolution of this is a multi-agent system like the one on the right, where it handles complex interconnected systems, incorporates, let's say, you can see here, weather forecasts, user schedules, energy prices, and appliances, and generally makes autonomous goal-driven decisions. And some examples are the robotics, let's say, coordination, or the collaborating medical decision support. Another one is how a human planning process can be automated and streamlined using agents, basically for personalization. So we have here how to transform a process from idea to execution. You know, in order to organize a trip, you should decide the place to go, book flights, hotels, tickets, compare costs, pros and cons, sightseeing. The chart on the right, it's a flow, it's a logical flow to select the city based on budget, days of stay, all other factors, and finally create the whole package. So these applications could be evolved by far. Some companies have built such agents to their customers. Now I will show you some advanced Gen AI concepts. We have the context engineering, which is an emergent discipline in the field of AI. It's a significant evolution over the traditional, let's say, prompt engineering. While prompt engineering focuses on crafting, let's say, the question or the instruction, the thing you say to the model, let's say. Context engineering is about orchestrating everything the model sees before it generates a response. What's the difference? Context engineering takes dynamic context into account in order to accurately answer to a user query, taking into account the most updated information. That's why the tools is one part of it, web scraping, and search engines and so on to retrieve the information before the answer retrieval in real time. We have the memory, a long memory, in order to the system to even remembers past conversation of the same, let's say, person, or taking into account all the other conversations. The memory, let's say, advantage, and the orchestration of all these procedures in order to have a dynamic AI system. Here we have an application, an alpha agents. It's an application which a multi-agent application with 3 agents. The fundamental agents processing financial disclosure documents to understand revenue papers, to understand, let's say, how stocks, bonds, and so on behave. We have the sentiment agent, which searches over the web to find and analyze financial news. And the valuation agent, which basically analyze time series data, compare companies, trends, and so on. So all this information is combined together in order to have a recommendation about an investment and the reasoning behind it. It's a real framework called Alpha Agents, this one. We have the OM agent, a multimodal agent. We have a video RAG. We have seen RAG before regarding text. Now we have RAG also on video. So the query is broken down in 3 parts by a vision language model, which can process the video. Afterwards, we have the processing of the video frames, mainly. ASR procedure, which processes audio, OCR procedure, which processes the text inside the frames, and that procedure, which basically is the object detection, scene detection, environment detection, and so on. All these information, parts of information are stored into the relevant databases. The information is combined together from these databases, and the visual language model, based on the human query, can let's say, respond with a personalized content from the video itself. Here we have the most high-end, let's say, I think, framework right now, which is the augmented reality, like the picture you see on the right. It is a deep reality framework made on TensorFlow and ONNX protocol. It's a neural network framework, basically. So we have the labeling of faults, of objects, and so on. We have the training with the TensorFlow to identify objects, scenes, environments, and so on. And we have the protocol which connects all the systems together, and we have the live instance, let's say, which depicts all this information on the live video. And at the last part about the technology trends today, let's say I will pick the most useful one. We have the cobots, the collaboration of humans and robots. This is a trend right now. The digital twinning, which basically some replicas, we try to implement procedures on replicas like cars, medical scanning, smart cities. We try to implement these procedures and in replicas, in virtual systems, let's say. These procedures could adapt afterwards to the community and the real life. The autonomous driving is a digital twinning, let's say, thing. The Google's dominance is at risk because the AI agents are evolving very, let's say, in a fast pace. So Google has to do more in order to keep on top, its position on top. We have the quantum computing. IBM and NVIDIA is investing a lot on this. Let's say, into the future, many procedures will be done in milliseconds and with higher accuracy than now. In 2030, it's, let's say, a year of target where quantum computing will be in action. And we have the multimodal models and the small language models I told you before. And the last one is the technical roles emerging in AI. We have the AI engineer, the back-end developer mainly, the prompt engineer crafting the response and giving instructions, the AI product manager telling about the AI strategy, application developer which has to do with integration, the AI ops engineer who have to do with deployment, data scientist who have to do with data analytics tasks, AI safety engineer who have to do with safety principles and security, synthetic data engineer having to do with validations and new data, let's say, generation, the AI agent developer, a whole agent developing with many tools, let's say, and the model evaluator to evaluate model as his exclusive, let's say, action. And thank you for listening to me. It's the end. I hope you had an insightful session, let's say. And if you have any question, please. Performance, you are talking about a specific slide? Ah, this one? Yeah. Each of these leaders have developed an evaluation, let's say, framework with some criteria behind it in order for a score to be created. For example, LA Marina is creating the ELO rating. This rating is basically an average of all the text tasks you can see on your left that a model could perform. So an average score is given, and if you go to these sites, you can have also other graphs. These screenshots are from 2 days ago, like they are very recent. You can see that there are also graphs about the challenger models, about how many times a model is winning another model. And at this point, Gemini 2.5 is one of the best, if let's say, regarding the text tasks. But regarding the vision tasks, GPT-5 right now, for example, is superior to this. But as I told you, in ChatGPT-like architectures, there are multiple models, let's say, behind. So when you ask something, you don't know, you can see which model runs behind it. For example, you don't know if ChatGPT uses the, let's say, GPT-5 at the moment, or the O3 reasoning model, or the vision model of or the OpenAI and so on. Maybe all these models run, and the let's say the findings are combined together. But yeah, regarding rating, it's let's say evaluator built a blueprint, let's say, of evaluation methodology. And as I told you before, the best, let's say one of the best to do it is to use other models to evaluate either these ones or even AI agent themselves. And you have to have also the ground truth in order to directly compare them. Okay, in classification tasks, it's easier to evaluate a model. You have accuracy, F1, recall, and so on. Regarding unstructured content, the situation is more complicated, let's say. I don't know if I have answered to you, but any question? Or you can find me here or outside. Thank you, guys.